I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Relevel. So in this video, we are going to move forward one step ahead from talking about keys and move on to the next aspect of normalization. So if you have not watched the videos for keys yet, I would recommend to go past that video first, watch keys, and then come over here. Okay. Now we are going to start with the next topic, which is normalization. Now normalization as a topic is required in databases, and it is very evident to use in DBMS as well, which is used to used to reduce redundancy in data. Okay, but before actually taking a look at what normalization is, we are going to talk about in detail what functional dependency it is. Because functional dependency as a topic will be very important and will be used a lot of times when we will study normalization. So it's always good to take a look at first this topic and then move to normalization, because when we will study normalization, we would already have a good idea about what functional dependencies are. Okay, so let's quickly go ahead and understand this topic. So functional dependency is a relationship that exists between attributes. Okay, so attributes are nothing but characteristics of entities, right? And now we are talking about functional dependency that tries to define the relationship between two attributes for an entity. Okay, it typically exists usually between the primary key and the non-primary key attributes within a table. So we usually define a relationship between primary key, right? Usually we try to define a relationship with primary key and non-key attributes of a table. Okay, that's what dependency, right? Dependence over here. So we try to define it in a way and represent it that X arrow Y. Okay, now the left side of the functional dependency is known as determinant, and the right side is known as dependent. Okay, so when we do X and Y, this is how we try to define functional dependency. Okay, and in this side, the left side, whatever you has is basically known as determinant, and this is known as dependent. Okay, so it basically is like that Y is dependent on X. Okay, that is what it really means. Now let's take a look over here. Assume that you have an employee table with the attributes employee ID, employee name, and employee address. Okay, so we have, let's say, an employee table with the attributes over here. We have the employee ID. Okay, what else do we have? Employee name, and we also have the address of the employee. Okay, so here the employee attribute can uniquely identify employee name, right? Once you know the employee ID for a particular employee, you can immediately identify the employee name with that as well, right? Because we know that employee ID, if we know, we can easily associate the employee name with that, as employee ID is unique. So based on that, the relationship that we draw is that employee ID and employee name. That means employee name, if you need to know, it is dependent on the employee ID. Okay, and we can say like it shows over here that employee name is functionally dependent on employee ID. Okay, that's how you represent functional dependency. Now the next thing is, what are the different types of functional dependencies? Okay, so we have a total of 2 types of functional dependencies present. Okay, we have the first one as trivial and the second one as non-trivial. Okay, two types of functional dependencies are there. But remember before that what exactly functional dependency is, right? You write the determinant in the X place and you put an arrow and then you put the dependent. So the dependent thing is depending on the determinant. If you have to know the employee name, you need to know the employee ID. Okay, that's what the overall idea is. Now we classify dependency or functional dependency into two types, trivial and non-trivial. Let's take a look. So when we talk about trivial dependency and we write A dependent or B dependent on A, it means that it has a trivial functional dependency if B is a subset of A. Okay. For example, you consider a table which has two columns, employee ID and employee name. The table similar what we already saw. Now, can I say that using employee ID and employee name, I can uniquely identify employee ID? Correct? That is correct, right? And that is pretty obvious as well. If you know someone's employee ID and if you know someone employee's name, then obviously you can know the employee ID for that person as well, right? That's pretty much obvious. And here this was A and this was B. And here very well B is a subset of A, right? Then we can very easily say that this is an example of a trivial functional dependencies. Okay, and similarly with that, this is one example of trivial dependency, this is also an example of trivial dependency, and this is also an example of trivial dependency. It's like saying using employee ID you can find out the employee ID, using employee name for a person you can identify the employee name. Okay, let's go through it once quickly again. A to B has functional trivial dependency if B is a subset of A, if the dependent is a subset of determinant. The following dependencies are also trivial where A is to A and B is to B. Okay, and the example says that consider a table with two columns, employee ID and employee name. Using employee ID and employee name, we can depend or find out the employee ID. Now, this is an example of a trivial functional dependency as employee ID is a subset of employee ID and employee name. Also, employee ID to employee ID and employee name to employee name are also functional dependencies. Okay, so I hope with this you understand what trivial functional dependency is. Now, let's talk about non-trivial functional dependencies. So when we talk about non-trivial functional dependencies, it means that A to B has non-trivial functional dependency if B is not a subset of A, which was the example that we took over here. Okay, this is an example of a non-trivial functional dependency, okay, where we have a dependency from A to B and B is not a subset of A, right? Employee name is not a subset of employee ID, okay, and that means it is a non-trivial functional dependency. When the intersection of A and B is null, right, then A to B is called as complete non-trivial. When you try to find out the intersection of A to B and if it comes empty, this is a mathematical way of writing that the intersection of A and B is null, then it is called as not just non-trivial, it is known as complete non-trivial. Okay, and that is what it says over here. Alright, using ID, you can determine the name of the person, or let's say if you have the name of the person, you can determine the date of birth. Okay, so that is pretty much what the concept of functional dependencies is. Pretty much the concept of functional dependency is quite easy to understand. There is nothing too complex about it or too difficult to understand. The concept is very simple, that we try to define dependencies, right, where y is dependent on x. Okay, dependent is depending on the determinant. Using, and if we have the determinant, we can identify the dependent uniquely. Okay, and we took an example where using employee ID, you can use the employee name. And then we talked about what are the two types of functional dependency. We have a trivial functional dependency and we have a non-trivial functional dependency. In the trivial functional dependency, if we have a dependency from A to B, right, B is a subset of A. Whereas in the non-trivial dependency, if we have a dependency from A to B, B is not a subset of A. And that is what we took an example to understand as well. Okay, so like I said, functional dependencies actually form a very important part in order to understand the concept of normalization. Now that we have good context about what functional dependencies are, we can quickly move ahead and talk about the concept of normalization. First, let's take a quick definition. So whenever we talk about database normalization, it is a technique of organizing the data in the database, right? So it's just a technique where the data is still there which you want to keep, but it is going to be organized in a certain manner. Okay. Now normalization is basically a systematic approach of decomposing tables to eliminate data redundancy. So the main objective of organizing data in normalization, in the concept or technique of normalization, is that you eliminate data redundancy, right? You don't want repetitive data. So you organize the data in a certain format, you decompose or you break down the tables in such a format that the repetitive data basically gets eliminated and undesirable characteristics, right, like insertion, updation and deletion anomalies also go away. So there are three kind of anomalies which are present whenever we deal with data. So using normalization, we get rid of not just redundant and repetitive data, but we also get rid of some undesirable concepts like insertion, updation and deletion anomalies, which we will cover as well, okay, in the next slides. So normalization is not just a one-step process. You don't just do something and immediately remove redundant data. It's a multi-fold process. It's a step-by-step. It's a multi-step process that actually puts the data into a tabular form or in such a format that we remove the duplicated data. Okay, just to quickly summarize, it's a technique for organizing a data, right? It's a systematic approach where we decompose the data and get rid of redundant and repetitive data and insertion, updation and deletion anomalies. And it's not a one-step process, it's a multi-step process so that we get rid of undesirable data. Okay. Now, normalization is mainly used for two purposes. First is, again, like I told you, to eliminate redundant or useless data and make sure that the data dependencies make sense, right? The functional dependencies that we have, it actually makes sense and the data is logically stored, right? When you have data in all of the tabular format, it logically makes sense to store something in a particular entity and in terms of particular attributes. Okay, so we organize the data full way using normalization and it helps solves a lot of problems. Okay, all right. Again, to answer the very important question about why do we really need normalization, the main reason for normalizing the relations is another word that we use for tables, is to remove these anomalies. Failure to eliminate these anomalies means that you are not able to get rid of these anomalies, actually lead to data redundancy and can cause data integrity and other problems as the database grows. Okay, so what will happen is initially if you don't get rid of these problems and if you don't introduce normalization, you might be able to live and sustain for some time. But as your database will go, as your data will grow, it will become so complex and so much redundancy will get introduced that it will cause a lot of problems. Okay, and using that and for this purpose itself, we basically introduce normalization. Normalization consists of a series of guidelines and multi-steps that helps you to create a good database structure. So we will actually study different normal forms, different guidelines, which actually help to ensure that we get good database structure. Okay, data integrity is one word you see over here. There is a video on relation modeling where we have talked about data integrity. So if you have not watched this video before, I would recommend to watch that as well to understand what data integrity means. Okay, it's basically a problem that gets introduced in databases sometimes. Okay, and normalization very well gets help to get rid of these problems. Now, what we'll do is we'll first also take a look at what are all the problems that can be introduced if we do not use normalization. Okay, let's say even after telling all the benefits, somehow someone is not convinced about what normalization really helps. They don't want to go to lengths to learn another topic because it kind of is an overhead for them. They just want to move on with the approach that they are following for designing databases. So it's very important in these scenarios that we help these people to understand what all problems can happen in a very systematic way. So let's do that. Now assume if a table is not properly normalized and if it has data redundancy, then it will not only take up extra space, but it also makes difficult to handle and update the database without facing any data loss as well. Now insertion, updation and deletion anomalies are very frequent if the database is not normalized. So three kind of problems that come up very frequently if your database is not normalized, and those are insertion, updation and deletion anomalies. Okay. So what we'll do is we'll try to help understand the concept of normalization with the problems that can happen if normalization is not there. And what all three problems can happen, we just named all of them. Okay, so what we'll do is we'll understand all of these anomalies one by one by taking an example of a student's table. So let's take a look. There is a table in which the first column is roll number, okay, which has different roll numbers of the students. Then it has the name of these students. Then it has the branch in which those students basically are. Then it has the HOD for all those students, and as well as what is the office telephone number for that particular school. Okay, because usually office telephone number is for an entire school, right? And HOD is also for like a bunch of student and a range of classes of students. Okay, so now this is a simple kind of data where everything has been stored together, no normalization, nothing has been introduced. Okay, let's repeat it again. We have roll number, we have name, we have branches of all the students, right? We have the HOD for all the students, and we have the office telephone number. Okay. Now what you will see is in the above table, we have 4 computer science students, correct? Here you can see there are 4 computer science students because all of them belongs to the same branch. Now as we can see, data for the fields branch, HOD and office telephone number is repeated for all the students because all of them are in the same branch in the college, correct? Here what you will see is that storing the name and the roll number is fine. But the problem is that branch, HOD and office telephone number is same for all the students, and it will be same as well, right? Because if all the students belong to a particular branch, their HOD will be same, right? The office telephone number to contact the branch is going to be also the same, correct? So this is the problem of data redundancy. There is a lot of data which is redundant and same for all the students for a particular branch, and you introduced a very new column for this. Now, first problem that comes is insertion anomaly. Now let's assume there is a new admission, right? Now until and unless the students actually opts for a branch, right, the data of the student cannot be inserted into the table, or else we will have to set the branch information as null, correct? Let's see. Here, what all were we storing? We were storing the roll number, the name, the branch, the HOD and the telephone number, correct? Now what happens is, let's say you already have a bunch of students and now it's a school only, right? So you have a new student who got admitted in your school, right? Now the moment the student got admitted, he's not going to choose his branch, right? It takes some days, sometimes it takes like 2-3 weeks sometimes to make the decision of what branch to want the student comes in. But the problem is, since you are storing the branch in this student table itself, right, you cannot really make an entry for this new student until and unless he or she chooses a branch, right? Because if the roll number is, let's say, 408, you will be able to do that. The name also you'll be able to put that. But since the student has not chosen the branch right now, how will you populate this particular column, right? Either you will have to put null, which doesn't make sense because a student cannot have a branch null, right? He or she has to be in a branch. But otherwise, if you do not want to put it null, you will have to wait until the student actually chooses, right? And that's what it says over here. Suppose for a new admission, until and unless a student actually opts for a branch, right, the data of the student cannot be inserted, correct? Or else we will have to say let's assume that is not just the only problem. Let's assume if we have to insert data of 100 students of the same branch, right? Then all of the information like branch information, HOD, a telephone number, all of these will be repeated, right? Let's say now I add 100 students more. Now the problem is I will have to write the same branch 100 times. I will have to write the name of the HOD 100 times again, and I will have to do the phone number also these many times again, right? Which is definitely not the good way to do this, right? I do not really want to do that. This is so much of redundant data where I already know that for a particular branch the HOD is always going to be the same and the telephone number is always going to be same as well. Still I am storing all
कहाँ मनोज? घर में, रूम में।
all of this again and again over here. Again, this is nothing but an example of insertion anomaly. Okay, not only are you dependent on the branch or let's say some other information till the time you make an entry for that student, as well as you're having so much redundant data, so much same data again and again that you have to store and undo. So whenever I have to make an entry, I will have to put the HOD name also and telephone number also. That is nothing but what we call as insertion anomaly. Okay. Next, we talk about updation anomaly, right? What's the problem in that? Now assume for 2000 students who were belonging to the branch CSC, you wrote their HOD as X. Now assume the HOD leaves the school. Now what? Or let's say the HOD is no longer working for the computer department. In that case, you will have to update all the 1000 records for all those students, right? And by mistake, even if you miss one record, it will lead to data inconsistency, right? As you can see over here in this table, since the data is not normalized, you are storing the HOD name for all 1000 students. Let's say in the computer science branch, I have 1000 students. So you have stored 1000 again, name again for all the HOD. And what if the HOD leaves the school or is no longer in the computer department? Again, the very big problem over here that you will have to update all of these 1000 columns, right? And put the new name. So this is a updation anomaly, right? Because you have to update the data, and in such a bad way because it is not normalized. And what if, let's say, you miss an entry for a student, right? What if for that student the HOD is still X and for all others the HOD is still Y, right? That is data inconsistency. The data is not accurate, the data is not consistent. So this normalization, if not present, can lead to updation anomaly as well. And the third one is going to be deletion anomaly. Okay. Now, what happens in deletion anomaly is that in our students table, right, you can see that two different informations are kept together, right? You can see in this table itself, two different types of information are kept together: students information and branch information, right? Hence, at the end of the academic year, if the student records are deleted, we will also lose the branch information. This is deletion anomaly over here, right? Let's say at the end of the year, right, you delete the records of the students, right? At the end of the academic year, you basically delete obviously the end of the students, because now they will be moving to the next class, right? They're not just like in CSE 1 anymore, they probably move to CSE 2, right? So what will happen is, because students and branches information is in the same table, so the moment you record students information, right, you will also lose access for the fact what their branch and what their telephone number was, correct? Let's say here you had all the class 10 students, okay, and basically you stored their roll number, their name, their age, their branch, their HOD. Okay. Now at the end of academic year, all these class 10 students will move to class 11, right? And the moment you will have to some more class 9 students will come to class 10, and you will delete all this data because you have to make space for all this class 9 students. Now the problem is, the moment you delete the student data and you just wanted to delete this data, but since the branch data is also stored here as well, right? Because of that, the problem happened was, the moment you deleted the student data, it somehow the branch data will also get deleted, right? So that is a very big problem. Because normalization is not there, because proper bifurcation of entities is not there, somehow the values that you did not want to remove also gets removed in this situation. So these are all the three anomalies which are present. Okay, so what all we talked about in this session? We actually talked about a lot of things. First, we talked about what dependencies are, right? We have determinant, we have dependent, and then we talked about the two types of dependencies. Then we talked about the concept of normalization. What is normalization? What does normalization basically includes? What are the purposes of normalization? And then we answered the question, why do we really need normalization? Right? Why can't we really live without normalization? What is the reason that we introduced? And the reason was because of three anomalies, right? We took an example and then we tried to explain that how insertion, updation and deletion anomalies happen. Okay, if you have stored everything in one place, there's no proper bifurcation and structure to the data, right? It will lead to insertion anomaly. You will have to add a lot of redundant data and insert it again and again. You will have to update also the moment one of the values gets deleted. And deletion is for the fact that at the end of the year, you will also have to delete all the values. Okay, so that's what the three anomalies are. Now, I hope this is clear to everyone, right? I tried to explain everything with examples so that you fully grasp what the topic is, and it actually helps you to understand how do you work on this overall idea. Okay. Now with this, in the next steps, we'll actually start with the multi-step process of how to introduce structure and normalization to the data. We've already talked about what will happen when normalization is not there. So now is the good time to introduce how do you actually introduce normalization. Okay. So thank you so much for attending this video, and I will definitely meet you in the next one. Bye.